Let us understand the arrangement of wheel and axle machine. Wheel with diameter capital D and axle with diameter small d are mounted coaxially. One rope is attached to the wheel and other rope is attached to the axle. So I will show the connection of this rope. So here this rope is connected to the wheel. Now at the other end, effort Fe is applied. Now suppose this rope is wound in this direction, then the other rope we have to wound around the axle in the opposite direction. So I will show the direction of wound. Now here is other rope which is connected to the axle. And at the other end here load Fl is applied. How this system works? Now both the ropes are wound in the opposite direction. Now when we apply effort Fe in the downward direction, then this rope will unwound around the wheel. And at the same time this rope will wound around the axle and this load Fl will move in the upward direction. Now in the same way, when we wound the rope around the wheel, then at the same time this rope around the axle will unwound and this load Fl will move in the downward direction. Now we will find out the velocity ratio for this system. Now for one complete rotation, what is the distance moved by wheel? So for one complete rotation, because the diameter of wheel is capital D, distance moved by effort is equal to, because effort is applied to the wheel, so distance moved by effort is equal to pi into capital D. And in the same way, distance moved by load. So load is connected to the axle with diameter small d. So distance moved by load pi into small d. So this ratio, that is pi d divided by pi d. So this pi is getting cancelled. So velocity ratio is equal to capital D divided by small d.
Given question, in a wheel and axle, diameter of wheel is 500 mm and that of axle is 200 mm. The thickness of rope on the wheel is 6 mm and that on the axle is 20 mm. Find the velocity ratio of the machine. The efficiency is 60% and load is equal to 1000 Newton. Find the effort.
Let us understand given data. Diameter of wheel capital D 500 mm. Rope thickness on wheel. So if we observe on both sides, rope thickness is there and this total thickness on wheel is given 6 mm. So how to calculate the effective wheel diameter? So we have to consider the original diameter 5 mm. Now on this side thickness of rope is 6 by 2 and on the this side thickness of rope is also equal to 3 mm. So how to write this? So I will write here 500 plus 3 plus 3, that is equal to 506 mm. Now in the same way, diameter of the axle small d 200 mm is given. Now the rope thickness on axle is also given. So this total thickness of rope on axle is 20 mm. So if we observe on this upper side, what is the thickness? 10 mm and on the lower side the thickness of rope is 10 mm. So how to calculate effective axle diameter? So this original 200 plus 10 plus 10. So I will write here 200 plus 10 is equal to 220 mm. So these are the values of capital D and small d. Now we will calculate velocity ratio. So for this wheel and axle machine, velocity ratio is capital D by small d, that is 506 by 220, which is equal to 2.3. Now we have to find out the applied effort, where the load is given 1000 Newton. So for the load of 1000 Newton, what is the value of effort? So efficiency is given. So efficiency is the ratio of mechanical advantage by velocity ratio. So 0.6, because 60% efficiency, that means 60 by 100, which is equal to 0.6, is equal to mechanical advantage by this 2.3. So mechanical advantage is the ratio of FL by FE. So now this FL is 1000. So when we put the value, then we will get the answer. FE is equal to 724.6 Newton.